Ever played cat and mouse with an actual mouse? Well, I have a tiny roommate who doesn't pay rent, and I don't want to harm that little guy, but I just want to relocate him to a more suitable home, like my neighbor's garden. No, just kidding. That's like mouse walking distance, you know. This little ninja would be back before dinner, probably bringing some friends. I need to take it somewhere it needs a passport to return. So I bought this humane mouse traps here, link in the description, which promise to be safe for humans and pets. But why stop at humane when we can go high tech? I'm transforming these dumb traps into smart mouse traps with Wi-Fi connectivity. I'll get a notification on my phone the moment this trap closes. Will it actually work? Stay tuned to find out. So here are my challenges for this project. First, everything will be battery powered, so the power consumption has to be as low as possible. Second, we need to reliably detect if the trap is closed without consuming lots of power. And third, we need to send a notification to my phone. The cheapest way that I know of to connect to a Wi-Fi is called ESP-01. It's a super tiny board featuring an ESP8266AX microcontroller. If we look at the pinout, the limitation gets clear. We only get 4 GPIOs. But that's more than enough for this trap. Also, it should run perfectly on 2 AA batteries. So this is what this mouse trap looks like. The way it works is that you open the door, it locks in place, and then the mouse crawls in, and the food will be located here. The door will close, and the mouse is trapped. How can we detect this using electronics? My first idea was to close a switch as soon as this door closes. If this closes, we could close a switch right here. But I tried different switches and buttons like this one. The door is too weak. I would need a limit switch, a very low Newton limit switch. Apparently I don't have one. And also, how would I mount it here? That's not so easy. What else could we do? We could paint this door white and then measure the reflection of light from the top. But that would continuously consume energy. I want to consume as little energy as possible. After all, it will be battery powered. So what else could we do? My idea is to use a very thin wire that will be placed like this, and it will be connected to one of these cheap female jumper cables, and then it will be placed like this. As soon as the trap closes, the connection is broken. My preferred schematic for this project looks like this. I'll put the ESP8266 into a deep sleep mode and wake it up using a GPIO pin when triggered. Alternatively, I could connect the trap wire directly to the reset pin, keeping the USB in reset state until our uninvited guest trips the trap. This approach would be power efficient, perfect for a battery powered device that might wait days for action. However, I need to verify that both deep sleep and reset power consumption are very low. Battery life is critical at a device that might sit idle for days, so let's do some measurements. After all, a dead battery could mean a dead mouse, starved to death in a humane mouse trap. The whole point is saving mice, not creating tiny rodent Hunger Games. The ESP-01 is cheap, but not exactly user-friendly. To make it workable, I built this breadboard adapter. For programming, I'm using a 3.3 volt FTDI adapter, which also powers the ESP. During Wi-Fi operations, this is actually pushing the poor FTDI chip beyond its limits. It only supplies 50 milliamps, which isn't enough. I'm not sure if it just dies or has some kind of thermal protection, though if it did have such feature, they would have probably bragged about it in the datasheet. Let's see how much it consumes when it is in reset. To my surprise, I measured 23 milliamps. I thought, ha! This must be the LED. Nope, it wasn't the LED. So based on this knowledge, I cannot keep the ESP in reset. This would drain the battery faster than my wallet on Prime Day. So I put the ESP into a deep sleep by using software. The result was remarkable. The consumption dropped to 0.01 milliamps. Could I put it into deep sleep and then wake it up with a GPIO toggle? It looks like this is not possible with the ESP8266. The ESP8266 can only wake up from deep sleep using its internal timer or by resetting the chip completely. I guess the ESP's unconsciousness is what you deserve for that clearance price. If we cannot put the ESP into reset, one option is to remove the power completely using an N-channel MOSFET. In this setup, the trap wire pulls the gate of the transistor to ground. When the trap closes and the wire disconnects, the pull-up resistor pulls the gate high and turns on the transistor. To save energy, I use a very large resistor. The downside is that the transistor will turn on very slowly, which can be dangerous for the transistor. When fully off, no energy is dissipated. When fully on, almost no energy is dissipated in the transistor due to its low on resistance. It's the transition that's dangerous, like a car stuck halfway through a railroad crossing. However, in this case it's fine because the transistor can dissipate 0.5 watts continuously and we won't even reach this power during the transition. Let's talk about software. The ESP will connect to my Wi-Fi and publish a MQTT message to my MQTT server that I use to control our smart home. A new Home Assistant automation will be triggered when this MQTT channel changes its state to 1 and sends me a notification. This even works when I'm not at home using Apple's push notification service. Pretty cool stuff. So after inserting my Wi-Fi credentials and MQTT settings, I press upload. The moment of truth, when you find out if you've built a smart mousetrap or just a very complicated way to drain a battery. And it works. So let's continue with the hardware. Now that my ESP is flashed, I decided to reuse my breadboard adapter for my trap circuit as well. Time to connect it to a battery. I only have this battery holder with 3 slots for 4.5 volts, which would be too much for our poor ESP, so I downgraded it using this bridge. Unfortunately, I have no fresh batteries, and the ones I have report a voltage of 1.4 volts, without load, which is horrible. I tried anyway and failed to send any data. I increased the number of bad batteries to 3, but that pushed the voltage to unhealthy levels, so I added a diode in series to drop it down a bit. Still, no success. So what about a 9-volt battery and using a Zener diode to reduce the voltage? What could possibly go wrong? Damn! Yeah, I could, for example, accidentally short the Zener diode, exposing my ESP to a lethal dose of voltage. So is this the end? No, I will just use this dev board. It comes with a built-in LDO, so I can power it off my 9-volt battery without frying anything. After inserting an irresistible amount of peanut butter, I put the trap into service. First night, first mouse. Second night, second mouse. Or was it the same mouse wearing a fake mustache? I'm in a psychological war with a creature whose brain is the size of a pea. And I'm pretty sure I'm losing. Please like and subscribe to this channel. And if you would like to know how I deal with Martins, then you should definitely check out this video. Thank you for watching. See you in the next video.